Of the 4 billion life forms which have existed on this planet, 3,960,000,000 are now extinct. We don't know why. Some by wanton extinction, some through natural catastrophe, some destroyed by meteorites and asteroids. In the light of these mass extinctions, it really does seem unreasonable to suppose that Homo sapiens should be exempt. Our species will have been one of the shortest lived of all. A mere blink of an eye, you may say, in the eye of time. As bleak as this quote by P.D. James is, it's not unthinkable that the quote might actually be speaking the truth. The processes that act on Earth's surface today are the same as the processes that have acted on the Earth's surface in the past. The present is the key to the past. Catastrophic events cover the Earth's record, and they represent the evidence in Hutton's fault. They are two sides of the same coin. On the first, there is the magnificence of such great events, and on the other, darker face, there is the extinction of life. During the aeon of visible life, we have seen 5 such events. They occurred at the end of the Ordovician, Devonian, Permian, Triassic, and Cretaceous, killing large numbers of life forms. Obviously, the spectators of these episodes must have enjoyed the special effects, but must have suffered from one side effect: extinction. In order of severity, at the top of the table we have the Great End Permian extinction, which occurred about 251 million years ago and killed nearly 96% of all animal species. The second, more enormous mass extinction started around 444 million years ago, at the end Ordovician, when 86% of species died in a period of 10 million years. 80% of animal species died at the end of Triassic mass extinction, 200 million years ago, and even lower extinction rates are connected to the late Devonian and end Cretaceous events. Merely observing the huge impact on life, the causes of such events must have been massive. Events that can almost instantly change the composition of air in the oceans. Any guess? Ice ages, meteor impacts, global warming, or intense volcanism? Unfortunately, I don't have the time to explain the real reason to you guys. Nah, just kidding. The truth is that no one knows with certainty what really happened. We do have many hypotheses concerning the probable biological causes, such as extraordinary hydrogen sulfide eruptions, astronomical causes such as meteorite impacts and gamma ray bursts, geological causes like geomagnetic inversions, clathrate gun phenomena and basaltic floods, and climatological causes like global cooling and warming periods and anoxic oceans. But when 2 geophysicists discovered a crater underneath the Yucatan Peninsula in Mexico in 1968, an incredible evidence of the impact with a massive asteroid around 66 million years ago was given. Furthermore, solidified layers of flood basalt have been identified, in particular in Siberia and in India, as evidence of the outcome of massive hot plumes producing an enormous quantity of CO2 that eventually caused intense global warming, oceanic anoxia, and acid rain. What a beautiful setting this would be. As bleak as all the information about these mass extinctions sound, they have been essential in the process of evolution that has led to us existing today. Life was not always as we know it today. In the billions of years of evolution, life went through a series of events like mass extinctions, ice ages, and evolutionary milestones in order to become what it is today. There is one event that might be considered as significant as the emergence of life itself. The Cambrian explosion, as it is called, was a relatively short evolutionary event beginning around 541 million years ago in the Cambrian period, during which most major animal phyla appeared as indicated in the fossil record. Before the Cambrian explosion, most organisms were simple, composed of individual cells occasionally organized into colonies, like the Ediacarian fauna. Over the following 70 to 80 million years, the rate of diversification accelerated by an order of magnitude, and the diversity of life began to resemble that of today. A few of the morphological changes that occurred during this period would be locomotion and predation, the early development of a digestive system, sensory organs, and defense mechanisms, as you can see on this beautiful drawing of an opabinia. These changes allowed life to evolve at a rate never seen before, following the principle of natural selection. Examples of catastrophic events leading to the synthesis of new things are not limited to Earth, but can be found in space as well. To forge a sword, one needs heat. A lot of heat. The same is true for forging the elements that make up our universe and life. But where does this heat come from? One candidate is the Big Bang. At the first blink of time, the temperature of the universe was sky high, forging hydrogen and helium. But when the universe expanded, the temperature cooled and nuclear fusion stopped before anything heavier than helium formed. However, heavy elements are all around us, so where then do they come from? To find the answer we have to travel to the core of a massive star. where protons collide to form helium. This fusion reaction produces large amounts of radiation energy, countering gravity, making sure the star does not collapse under its own mass. Since helium is heavier than hydrogen, it sinks to the core of the star, and when enough helium is made, helium synthesis takes over. This sequence continues until the star's core begins to fuse iron, and that's when everything changes. When iron fuses, no energy is produced, and the star becomes denser and denser until it collapses under its own weight. This implosion creates so much energy that the star explodes. When it explodes, it produces a massive shockwave so powerful that atoms bump, forming elements heavier than iron, just like the force of a hammer forging a sword. It's clear to see that the universe is a constant shifting landscape, with disaster followed by the synthesis of new things. The massive amount of energy that is produced by supernova results in the elements needed for life on Earth. Life on Earth is then in turn wiped out by mass extinctions that can be caused by something such as a meteor impact from outer space. But mass extinctions in turn make way for new things to develop. All these things have eventually led to humans existing on this planet as we do today.